first speaker. Arik Freeman is a lead automation architect for Automation Squared in Brighton. He will be presenting a hands-on code demo. We've adjusted this slightly, haven't we?
Yeah, it's been adjusted slightly. There's no code demo as such.
He will not be presenting a hands-on code demo. But he will be, I was going to read this anyway, that combines the topics of artificial intelligence and machine learning in the real business world. Can we please make Arik feel welcome?
Hello, I'm Arik. I did initially plan to give you guys a sort of hands-on code demo in Python and Bash and something else, but yeah, quite honestly, it was really difficult to get something to fit within 20 minutes, and I decided to not scrap it. I will be able to make it available over the next couple of days if there is a demand for it. Otherwise, if this is too boring, then well, you just won't bother, I suppose. Anyway, so I'll still be giving a fairly technical overview of a developer's introduction to machine learning and its potential benefits in the marketplace. So topic areas will, right, okay, I forgot to update that. So the topic areas we'll be touching on are the pillars of data science. We'll assess suitable technologies. We'll go through types of machine learnings with examples and case studies. So hopefully you guys can identify some value in your own businesses or your own ideas and see what type would be most applicable. Quite honestly, I think the rest we'll probably not get to, so we'll just skip that. Yeah, so I'm Arik Freeman. I'm a software solutions architect. Work for Automation Squared. It's a company based in Brighton and Horsham. We are, well, we do all sorts of stuff. My background is in mechanical and manufacturing engineering. Otherwise, yeah, I've done app development for the last few years, full stack web development, RTC and WebSockets, which does help in machine learning and scaling, and software architecture and hardware integration. So we're doing lots of IoT stuff, and which is where really machine learning, I think, really comes to life and really has huge benefits. So hopefully I'll be able to get to a few case studies that will be interesting. Okay, so I pinched this off Google. I couldn't find the original author, but just imagine it's cut off on the screen. Machine learning really is computer science and a bit of maths and statistics. Technically speaking, data science is really useful. It's a bit like vocabulary. Even in English, for example, if you have a broader vocabulary, you have a broader set of tools to express yourself. And that's, I would say that is synonymous to data science. The more you're aware of what you can get out of data science, the more you can apply it with your IT stack. It does take a little bit of time to get into. If, for example, you did this sort of stuff in university and then you stopped for 6, 7, 8 years, it'll probably take another 2 or 3 years to get back into it, as it has me. Yeah. Anyway, so we'll be touching on data, technology, statistics, and subject matter expertise. That is really, I would say, the pillars of machine learning. You do need a good team. You do need pretty good or accurate subject matter expertise to make it work for you. Otherwise, it'll just be too broad, too generic, and you might get the minimal value out from it that you could. So one thing we don't already know is many of us are already well suited for machine learning. We just are not very aware of it. Loads of developers, I'm assuming half of us, maybe half of us here are developers as well. We're all actually perfectly suited to do or play some role in machine learning. Ultimately, though, machine learning is worthless without some business value. So really, sort of quadrants are data science, data engineering, business intelligence, data analytics. A combination of those all will give you tremendous value. And for a lot of us, we probably fit somewhere in there or do to some degree. I know it's very difficult to boil down a human into a couple of labels. So that was my best shot. If you do database administration type stuff, you probably have a really good idea about databases, technologies, streaming data, and normalizing databases, which is super important. When you do machine learning, lots of duplicates cause lots of anomalies, and it skews your data hugely. So having a good database administrator or that as a background is really quite beneficial. DevOps, looking at pipelines, for example, from the databases straight up to sort of code deployment and sort of production environment grooming, that sort of stuff, super valuable as well. That sort of borders on data science as well. If whether or not you know that, that is something totally different. Otherwise, yeah, business strategist, business intelligence type stuff, data analytics, all that stuff, even marketing, honestly, very, very valuable in machine learning, because that's how you're going to get the most value out of your data, is having somebody who has some idea of the direction that you really want to take it in. So I thought I'd look at some Google Trends. I have to admit, this is not as good as I thought it was. Google Trends, especially looking at languages, which I'll get to in the next slide. This is just, I suppose, to represent the interest in machine learning over the last few years, and as you can see, it's sort of gradually going up. China has apparently the biggest interest in machine learning, so this actually does take the sort of translations between Cantonese and all the 12 different variations of it, and all the languages that sort of translate to machine learning and what they search for, and comes up with a ranking system on who's responsible for the most data. So currently China, Singapore, St. Helena, apparently India and South Korea are the top 5. If we add data science in, which is really what you need to get some of this done, if you think of this as sort of getting more and more technical, machine learning is what you most likely find coupled with AI in news articles. Ooh, machine learning, woo! And you probably do a couple of Googles. Then you have fewer people who bother figuring out that it's data science that actually runs it all. It's actually a very, well, is the essential component to machine learning. So the curve is slightly lower than machine learning. However, it is sort of converging towards the end there, probably because people who've Googled enough of machine learning have decided, I'm not going to do this, or there's actually enough interest within sort of development circles to consider it very seriously. Okay, AI, I mean, look at that. AI is the yellow line. That is the buzzword that we'll see absolutely everywhere. So I just thought it would be interesting to see just how big the gap is between capability and expectation. So, oh yeah, having said that, sorry, I spun to that. The UK doesn't fare very well in terms of our search history for these stats. Netherlands is generally speaking a very prominent figure in development circles. So considering they're 8 behind sort of Israel and China, you know, it isn't so bad. It isn't so bad. But UK is 17, which I think is just rookie numbers. Anyway, so what I pulled out from that was there's a huge hype around machine learning and AI. It is investor candy, and everyone has huge expectations. Everyone thinks Skynet's going to happen next year. It might. Anyway, there's also very poor capability to meet expectations. All solutions are in their infancy, which we'll explore a little bit of now. We'll go through a few technologies that I've come across in the last few years and describe their weaknesses and their strengths. And yeah, it is the Wild West for machine learning at the minute, which is great because it's totally unregulated. There are no rules, so we can do what we want for the time being until GDPR gets us again. Yeah, okay, so companies not sure how to utilize machine learning. So recently I've been speaking to a few companies. I do a little bit of business development as well, where I am, and we tend to meet up with companies, and a lot of the time they've been hoarding 20 years worth of data, don't know what to do with it, don't know how to get value out of it, and don't even know what to start looking for in people to start initiating that. So that's something hopefully that we can start changing in the next few months. So, typical personality traits that I think is quite important, because you might find that you fit into these somehow. So everyone here is perfectly capable of being a machine learning professional, to some degree. Anyway, yeah, so STEM degree, science and tech, engineering, maths, is quite useful, and that's only because of the years it buys you in statistics, and and maths is awesome. Things that we can't see on charts can be expressed in maths. So I think a lot of the limitations that we have, what shall I say, we're limited to a 3-dimensional view of statistics. We always think in 2 dimensions, all the graphs and charts and whatnot. At most in 3 dimensions, because that's all we're capable of seeing, because that's all we do see. But maths, you can technically express as many dimensions as you like in a single equation, and it all makes sense. It just does. You have to trust the maths. Anyway, but apart from that, you don't need maths to be a data engineer, for example, which is primarily what development personalities get into, so software engineering, stuff like that. Data engineering is super fundamental, of course, because you need everything to sort of match up from databases to application to input, output, that sort of stuff. I have to say, though, that the data science stuff is more boring if you don't like looking at charts. Right. Moving on, we're going to look at suitable technologies for machine learning. We'll look at language considerations, the OSI layer considerations, because I think it's personally important. I think we have a sort of duty to be as efficient as possible when we design applications. And a lot of stuff that's available today has none of that in mind. And we'll go through some of them and just put red crosses over them. Okay, we'll also look at frameworks for getting into enterprises. I think what a lot of people do wrong is they go straight in for a framework that they've seen being, the most amazing thing on YouTube, and realize that they'll probably never ever need the capabilities that it offers, and now you've restricted yourself to an environment that is designed for something that you're never meant to really touch or play with hands-on, really. But we'll touch on this a bit later. Okay, so language considerations. Python being at the top, and that's simply because it's introduced in universities. In fact, can I just go a quick show of hands who has had any exposure to Python? Okay, well, that's, I would say, almost 50%, which it is the best stuff out there because it is pushed in universities as being super simple. Its philosophy is one way to do one thing. In many other languages, you can do the same thing in 20 different ways. So Python's it's a really good, easy entry point. It's functional, it's object-oriented as well. It is pretty fantastic. And because it's sort of pushed out in universities and as a really good entry point, people have built some really incredible packages to help you sort of get accustomed and hands-on with your data, which is part of the reason I didn't even bother writing something, because I found another package that's even better than what I could have done. So we'll come across that in a minute. Anyway, R is extremely fast. That runs on graphics cards, for example. Extremely quick. It is built specifically for sort of maths and mathematical data types, rather than strings and stuff like that that you need in a web application, for example. Julia, I have to admit, is probably the most impressive of this lot. I personally love it. It's if you have any idea what LLVM is, it's a foundation that its mission is to just try to get everything running as modularly and as efficient as possible. It's compilable on almost every single platform known to man. It is bloody awesome. Anyway, Julia is fantastic, really good for interacting with your data. Golang, that's Google's language released in 2012. Some good pros and some battles as well. We'll get around to that later. And PHP 7, which is a bit controversial because no one will consider PHP at all for machine learning, but it's actually bloody epic. So I've had a lot of fun with PHP 7. So if you have anything to say about that, don't say anything until after I'm left. And okay, Java and Scala are still, the Java environment is enormous. It runs on absolutely everything. However, there is the expense of that, especially with machine learning, is because of its environment sitting on top of everything, it's abstracted ever so slightly, and that doesn't give you the performance that you want. I mean, typically you'll lose about 15 to 45%, depending on what sort of data types you're using. So I personally wouldn't recommend those, but if that's the sort of path that you've been on for the last 10 years, then stick with it. It's perfectly fine for this sort of stuff. Oh, there was something else chopped off there. There's probably C++ or something, or C#. Never mind. Okay, so Python popularity. Yeah, I thought I'd just. C++ does matter, sort of. That's the green line on the second chart. I could only fit 5 at a time in Google Trends, so I apologize, I couldn't fit 10 lines. But yeah, so Python is the blue one, and it's just been increasing in popularity, and it is somewhat correlated with the interest in machine learning. It is the most easily accessible thing out there, I think. As for the other ones, I may have posted the same thing twice. Oh, no, I didn't, sorry. Okay, so yeah, PHP is sort of declining in popularity, but that's okay. It's not really built for machine learning anyway. Scala and Java, having said that, these are quite difficult to justify, I suppose, because if you're already writing in those languages, you wouldn't really be searching with those terms at the end of your search term. You'd be searching for very particular things in the packages that you're using. So even with Python, you wouldn't be writing how to do this in Python, you'd be writing how to do this in scikit-learn, for example. So these are almost rubbish. I'm sorry, I don't know why I spent so much time on these. But I left the links there anyway, just in case you guys want to have a look and play around with the data. It is quite fun. I will go back to one thing. Oh, it's not there. I took it out. Never mind. It was quite funny because Go or Golang had this enormous popularity trend. I thought, oh my god, that's ridiculous. I can't believe how popular it is. Then I realized that there was an enormous spike in 2016. I thought, oh wow, what happened in 2016? So I went to Go and in the wiki it said, oh yeah, in 2016 we released these 32-bit binaries and instruction sets so you can run machine learning stuff on 32-bit compatible devices. I thought, okay, I don't know why that would be such a big deal. Anyway, I found out a bit later that Pokemon Go was released around that time, and it was totally skewed the results. So, never mind. Anyway, so Python. Why it's so good is because of these things. So you've got really useful Python libraries, and this is only a subset. I mean, these are just the three that I was actually going to include in the code tutorial, which I still can release at some point. But there are about almost 100,000 to do with data science. But these ones are the easy ones to get into. So for example, NumPy is just, when you have good data types, they inherit a lot of cool functionality with it, which makes things super quick. So almost like lazy loaded in before you start treating your data. Anyway, so NumPy, SciPy, and Pandas. Pandas are matrices. I took a little snapshot here for scikit-learn, because this is the sort of stuff that it does out of the box. It's really hands-on. You can start playing with the data, and you can see how it changes the data as well. So that's a really visual way of sort of starting to interact with your data and try exploring, I suppose. It can generate 500 charts for you in half a second if you really wanted to, depending on how big your data set is. It does some automatic sort of preparation of your data. I was going to go through an entire process of getting an application running, starting with sort of prepping your data, making sure that getting rid of duplicates, getting rid of null values. You don't want those. Those really do retard an application greatly. Anyway, so TensorFlow is, I don't know if any of you guys have heard about that one, but it's probably the largest one ever. And I've used it a couple of times. But for example, if you want something to play with in your office, then you can use something like Keras or something. Anyway, Matplotlib and Seaborn are just visualization packages. But if you are in marketing and stuff like that, it's a really useful no-code solution for you to start looking at your databases and just playing around, have a fiddle. Okay, so the OSI layers. I thought this was fairly important because I was saying I think we have this sort of duty to be as efficient and as direct as we can be. When you whack on the framework, you've already inherited massive bloats, I think. So when you're first starting out, I think it's important that you start out with the very, very sort of basic essentials. You start out with, as simple as you can, with functional programming, for example. Don't use a big framework because you'll get bogged down within its constraints. A lot of the time, let's face it, you probably won't be an enormous Microsoft-sized enterprise in the next 3 years, and by that time there'll be something even better. So don't even bother. Start with the small stuff first. Appreciate the principles, and then you'll realize what is the frameworks, what the value is that frameworks bring. Anyway, so machine learning is primarily seated quite nicely on levels 5 and 6. So the transport layers, or TCP, UDP, the application layers, these sort of input-output, HTTP, stuff like that. Sockets sort of sit quite nicely anywhere between 4 and 6, which means massive streaming capabilities. The great thing about sockets over HTTP is HTTP is a sort of request-response framework, which comes with the huge headers all the time. So back and forth sending a massive payload, it's just not good for latency. Whereas if you have a WebSocket or a socket of some sort, headers are sent, once they're accepted, handshakes were made, you literally have a sort of direct channel between your clusters and your servers. And that does cut down latency. It literally shaved off about 6 days from one of our data exploration things, just because we had a latency. Cut down from, I think, it was about 6 seconds per hop from clusters to about 0.4 seconds, which was, phenomenal. Anyway, so I thought that was worth mentioning. You don't need to be aware of this at all, really, but I think it is just something to be aware of in future when you do start looking at the frameworks, because the frameworks will offer different benefits in different layers. So you'll have application layer or presentation layer benefits where you can have loads of clusters, and you don't care where they are in the world, how they're put together, but you know that they're available as resources through a socket. Whereas you might have hardware-based optimizations with different frameworks, which would be sort of better for clusters that you manage in-house or virtual machines, because that you do need some umph for that stuff. Anyway, so that's the only reason why I want to bring that up. Right, enterprise stack solutions. Okay, so Apache Spark is probably one of the biggest ones, I've got ahead of myself from last time, sorry. So this is cluster computing environment, rapid streaming and queuing. So if you have really old infrastructure, for example, Apache Spark can help just by queuing everything, so your poor haggard MySQL database can actually cope with the load. The queue will sort all that out for you. Hadoop is slightly different because it's distributed processing across the clusters, as I was saying. It's sort of on the application layer. It does offer awesome redundancy, for example, in hot swapping. So if you ever had a NAS drive or something, or a NAS machine, and one of your hard drives craps out, you stick that one in, it just catches up by itself. Quite simple, except it's all virtual with clusters. You can add clusters, remove them, confine them, give specific resources to very, very specific things. So it just helps with your management of your data. Anyway, and those two, for example, are widely available on Microsoft Azure, AWS, and Google Cloud Compute, Google Cloud Enterprise, as deployable assets or within containers, so Kubernetes or Docker, for example. So that's gone over what anyway, so Amazon SageMaker is Amazon's version. It's fully managed, but I wouldn't. Don't even bother. Don't even bother. It is a lot to get into. Amazon services are there's like 500 of them. It's so difficult to get your head around. Right, okay, that little picture was there for a reason. Okay, yeah, so that's what Apache Spark does. It handles your SQL for you, it does the streaming. So you have multiple clusters of these, of course. And MLlib is a machine learning library that makes statistics. And going back to what I was saying about like vocabulary, that has all the vocabulary. You just need to be aware of what the vocabulary is to get the data out of your, to get the value out of your data as quickly as possible. And GraphX, that's an interactive library to help you manipulate your data. So three types of machine learning. I won't really go through much detail on these because I think one of our more experienced speakers, Mr. Prasanna, I think has a strong case in these ones, but I will go through these. In fact, how much time do I have left? Just out of interest. 5:10? Okay. All right, I'll put up some babbling cues so I can babble a little bit on these ones. Okay, so supervised learning is arguably the most boring, and you don't need much for that, really. Honestly, you don't even need Python. You can literally use Bash. You can use Notepad and Bash. Okay, Notepad and Bash will do this for you. And this is almost, I would say, the easiest entry, I suppose. So if you know what your data is, because you've had a great data engineer, you've structured data very well, your applications run fluidly, you just want to maybe find out how you can improve your sales or improve your efficiency or improve clickbait. How do you get people to interact with you more? This stuff might be useful to some degree. And that's when you know enough about your data and their data types, and you sort of have an expectation of what the results should be. So, for example, alright, so really awful example, I hate this example because it is so boring, is just finding out how long it takes you to commute home, given the time of day now, given the weather, and given if it's a holiday or not. So 3 simple independent variables will affect the dependent variable, the commute time, for example. So if you've got enough data on the weather, time of day, holiday, I mean, Google obviously has taken this 5 steps further, and they've got some awesome machine learning to predict the weather and this and that and the other. But it doesn't mean you can't have a play with this and you can have some fun. But yeah, you'll come up with a really awful equation that only takes 3 inputs and gives you 1 output. But that technically is something that you can do on a large scale. So you can deploy the same equation on a web application, for example, and every user, depending on what we can pull out from their browser, where they are, we can pull weather from that, where they are, what the roads are like, time of day, and if it's a holiday or not, nearing 5 o'clock kind of thing. If it's before 5, add 20 minutes, add 40 minutes, depending on how long the commute is. So that's just a really simple sort of supervised learning example, which is kind of boring, so I just, 1 page is good enough for that. Okay, so unsupervised learning, this is where I think it really gets fun. Anyway, so this is really learning by trial and error, and this is when you have absolutely no labeled data, and what the value that you can get from this is actually, you don't need to know what the data types are and what the relationships are necessarily. but you can sort of start categorizing them. And this is where you sort of get the sort of multi-class classification. And why would you do that? Just learn how to categorize and how you choose to treat each category. So if, for example, somebody comes on your website at 2 o'clock in the morning, he's definitely in the UK, he's not using VPN, he probably doesn't have a job. So you can send him notifications any time of the day. Or in the morning, when he's not awake. So when he wakes up, he's got it. And that's a terrible example. I'll go into a better one. Okay, so, oh, is that the same one? Yes, okay. So one of the case studies that I thought would be quite cool to mention is we do lots of engineering type stuff. We recently picked up something from the rail industry, and this was the health industry, never mind, another one. So the idea for this one was to help people who have missing limbs back to work. There's a metric, I couldn't remember what it's called, I ran out of time, but there's a metric that determines if someone's fit enough to go back to work. And that is actually, it's a traumatic thing. I haven't got a missing limb, but you know, if I did, a lot of the time it is the mental aspect of it that really makes it difficult for you to get up in the morning and go about your daily lives. We had clients, wonderful lady came in with this project. It was all about VR and stimulating people in such a way that it would make them feel more confident and just get them to the point where they would be happier or more confident to face the public again and go back to work. This is a terrible snapshot, okay, but for example, if we had 5 variables, or 4 variables even, independent variables and 1 dependent variable, session length, content length, BPM, feedback, I mean, the content itself can have all sorts of other bits and pieces that you're unaware of. And that's part of the beauty of unsupervised learning. You can learn how well people respond, for example, from their heart rate. I mean, there's so many other metrics. We were measuring how much of a particular hormone they had in their sweat as they watched these things, so we could track or correlate the BPM to that, to how they felt afterwards, given their feedback score. So we'd get a gradual idea, or the code would, anyway, the data would show us a gradual increase to willingness to go back outside and back into work. I think it was a cool project, and what we learned was the content was rubbish, so we needed to tweak that. So we started personalizing the content based on a sort of subset of users. So those were effectively what we trained the data on. They would use the system, day and night for a few weeks, and give us sort of feedback on each thing. And then we would try and figure out what sort of personality or what sort of category you'd fit better into, and see if we could feed you the same content we fed the other people in that same category to get a positive response, which we did, which is quite cool. Anyway, so semi-supervised is when you have a bit of both. So you've earmarked bits and pieces of data that you know are valuable. Maybe you've specifically earmarked usernames and bank account details for GDPR purposes, just so they'll be excluded. But you can earmark all sorts of stuff that you know are relevant. So right off the bat, you can say, right, okay, users buy products, these products like this, that, and the other. You can earmark certain bits if you want to pick up their behavior, how long they spend on each page, what colors they like, what they like to click on. Might be images, might be buttons, maybe neither. You can pick up loads of stuff that you know are going to be valuable, and let the data be returned to you. So you will then find out what things are correlated to that. However, correlation doesn't necessarily mean causation. That should have been a slide, sorry. It's just, I think, all the fun stuff is in unsupervised and semi-supervised learning. So this one, I think, so here's a snapshot from one of our clients. They have some engineering equipment, and we were trying to detect faults and sort of give them an early warning system. So they have pumps that are running, 9-10 hours a day, I think, and they take a reading every second of all the inputs. It's sort of chopped off there. There's another 15 or so. But when they make it to point, it's all bespoke. When they go to a new site, they need to build something that's going to fit and work for that specific purpose. But a lot of the time, for example, if you now need 20 meters of piping to get your fluid across, you might need a bigger pump, you might need more kilowatts, you might, they don't know exactly 100%. The theory in engineering is always there, but in real life, It's, we don't have a perfect world where it's just nuts. Nothing ever works like it should. Engineering degrees are just wrong, honestly. You'll learn everything about what you shouldn't do in your life. But in a way, it kind of means you kind of figure out what you can do. But in this particular situation, we log every second, in fact, now every 10th of a second, for a full minute, and then at every 60 seconds, we delete the last minute's worth of data. So if there is a failure of some sort, we have exactly 1 minute's worth of data at every 10th of a second of the environment before that happened, which is really cool. So that way we can also we can take a look at the frequency of failures of particular parts of part numbers, for example. We can say, okay, these parts we bought from XYZ, they're terrible because this keeps failing. We have the data for it. Stuff like that. So that gives them an early warning system. It takes measurements on some, I can't actually talk about too much. I don't know what I can talk about anymore. I'm sorry, I'm going to have to move on. Okay, so 3 minutes left. Okay, quality, and so reinforcement learning is probably the most interactive and the most fun. This is when you can get involved and start actually guiding your results. I was going to use a really corny example like Google did, but everyone used it. But if you haven't heard it, the one with the paddles and the balls, and you reward the machine for not letting the balls in. Okay, if you haven't heard it, great. Okay, I'll use that one. So this is all about rewarding the system, I suppose, and that's just by giving it points. If it knows what it needs to do to get more points, it will then do more of that, or be better at it, or be more efficient at it. Yeah, this is when the outcome is known, and a better score is a better outcome. So those are the rules that you need to give to the application, and that's what it needs to do better with the data that it's got to make better data. So you've got the basic rules. Could be a basic equation, could be anything, but you need to suggest the preferred learning dimensions. So, for example, if you guys ever played that game, it's like pinball, except it's not pinball. You're against someone or against 3 other people, and you'll have your little paddles. You have to move left and right and block the ball that's bouncing around. So Google did a cool little code giveaway a little while ago. It was quite fun to play with. But basically, the system would get points if it prevented balls from going in its own goal, right? And it would get even more points if it got balls into your goal. As lovely as that sounds. Anyway, so after training it for a little while, first of all, you sort of play yourself. You play your friend, for example. That is your initial seed data. And now that might be enough for the machine to start learning from that and say, right, okay, I need to sort of find something that gets similar data. But then you start rewarding it for doing better than that. So you start saying, okay, right, we want this to be lower, we want that to be higher. So we'll give you more points for that. The system's aware of that. It'll start reacting more, more unpredictably. In one case, we saw the bar grow, the total width of the gate, so it couldn't accept anything through it, which was on the rules in the first place, but it just shows that machines can technically bend the rules a bit if you haven't defined the rule explicitly to prevent it from doing so. So that was really cool, but that's just a reward-based system, I suppose. Well, what you can do with that data is, it's like the game's AI. We had one from Modern Warfare 2, if you guys ever played that, way back in the day when it was cool. What was really good about that game is it had really pathetic security, so you could download this hacking tool online, force your computer to be the host, and you could start putting game rules in it. So everyone had just a throwing knife or something, and a 1,000-foot jump and a 1,001-foot fall would kill you, kind of thing. But the cool thing about that was we actually got access to a lot of the host's data. So we would pull information from the best players, for example, who were always the campers who sit at the top of a hill and just watch for your heads to pop out behind a bush and shoot you. But then the AI could then learn from that and say, right, okay, the players who do the best tend to go in this particular area of the map and shoot in this direction. So that was groundbreaking. Honestly, literally, you had one bot that you'd introduce in the game that would just destroy us all in like a minute. But it's that sort of stuff, this reward-based stuff that allows, it's a different dimension because it allows the machines to learn totally independently almost. I mean, in the initial stages, you guide it, you help it, you give it the rules, If it does something that you don't want it to do, you can say no. I explicitly say do not cheat this way. It'll find its own way of cheating, which is really cool. It's not around the corner, but this is probably how we're going to do it. I wish I had a better example. I'm sorry, I've run out of time, so my slides get fewer and fewer, and there's no colourful images anymore. Oh yeah, there it is. The games, the pedals. Okay, chess, same as that. Works well in chess. I've done one myself. There's a really great tutorial. You can do it in Python as well. In fact, I might just give you guys that as your hands-on code tutorial and pretend I wrote it. I won't do that. And yeah, and game AIs. That might be the last one. Thank you very much. Sorry if it was a bit rushed.
Right. Take a breath. We've got any questions at all for Arik? Anyone here? I'd be keen, yeah, just from my point of view, really, just to find out how you got into machine learning.
All right. Okay. Oh, geez. Oh, yeah, this started about maybe 10 years ago. I had a small company selling custom PCs, all bought from eBay, and we just put it together and sell it. I got to the point where I would buy loads of stock because everyone's good at buying, of course. And then I realized that people weren't, because NVIDIA released the new graphics card or whatever. So I had loads of stock that I didn't know what to do with. I didn't know how to get rid of it. And what I wanted to do was to find out how customers would be tempted to engage with me and buy, one, this old stuff, and what I can sort of predict about what stuff they would want in the future. So it was actually a reasonable web scraper that would pull information from Novatech, which was a Portsmouth-based, at the time it was tiny, it was a sort of four-man show, but that way I would know whenever they had new hardware that that's what I should be marketing. So I didn't have to keep my stock. I could just sell stuff that I didn't actually have yet and order it from Novatech and sell it on eBay. So that's how I initially got into machine learning about 10 years ago with a tiny, really simple 12-line prediction engine. Because, yeah, I mean, unless you're watching NVIDIA and all that stuff all the time, like Intel, yeah, they do make periodic releases every quarter, every season. There's definitely something new. But back then it wasn't as consistent. So they'd say, oh no, sorry, this has been delayed. It'll be here next year. Oh no, it'll be here next year. And you didn't know when it was going to arrive, so you had to be the first one to pick up on when it would be there. So yeah, that was the sort of first entry into it. But I think the more I got into that, the next sort of stage was sort of marketing and trying to get people to the website and actually buy stuff. So it was just trying to figure out what people were drawn to. So everything that I was selling, things that I thought were important and super cool, like the best RAM you could buy, at the time the hard drives and the SSDs didn't exist. I had hordes of those. I just hoarded it because I thought it would be super valuable, and no one bought it. So yeah, it was really good to know what people liked on the website. So I integrated at the time, before it was Google Analytics, it was called something else. It came free with cPanel. But that would track users' clicks and what they hover over and what they spend most time in. And I figured out that more people like my mouse mats, so I sold more of those. But yeah, no, it was entirely predicted by a 12-line application for the best part of 5 years. Right. So before machine learning was a buzzword, or before AI was a buzzword for me anyway, I guess that was it in its infancy.
Okay. There's obviously loads more resources now available for anyone who's keen to get more into it. Where would you say the first point of call should be for anyone who's keen to kind of move into machine learning, or start to develop skills?
Yeah. So as I sort of alluded to at the very beginning, I think Python is probably the best place to start, and that's because it has the most support. It has an incredible community for support, and the packages that you can find they'll save you days, hours, and a lot of the time, I mean, you had to sort of think about what you wanted, and you had to be maybe a bit mathematically inclined to start looking at your data in the beginning. But as I was saying, there are loads of packages that have 500 algorithms in there, and they're designed to get you exactly specific value quantities out of your data. So if you just explore scikit-learn and SciPy is more what you type in, and scikit-learn is the more visual stuff, which I think is super valuable. But if you really want to start looking at the data that you've been collecting for the last few years, or maybe you don't have that much, but you'd like to start looking at it, it doesn't matter what stack you're currently on. All you need to do is give it access to a database, or an ORM, for example. Running robotics, and why that's a benefit. But that's a really good entry point. You'll find out how easy it is. Within, I think, 10 minutes on YouTube, you can probably pick up, it's called Jupyter. It's a Jupyter notebook. It's an interactive notebook. You have instructions, and you can start typing in, importing packages and using functions, and you can see your data in real time, sort of adjust, and yeah, you can play with it. So I think that's a really good sort of entry point. Python and Jupyter notebooks, which you'll find, I think now Amazon is issuing free notebooks as part of their machine learning campaign over the next 6 months, so that would be quite cool.
Okay, cool, fantastic. Any more questions at all? Any questions? Okay, great. If we could thank Arik again, brilliant.